Hi, I'm Cheryl Leach. The problem that we're going to be looking at in this video is a word problem that we've referred to as an optimization problem. Let's take a look. We want to find the length and the width of a rectangle whose perimeter is 80 meters and has a maximum area. Well, the first thing we want to do in our word problem is decide what exactly do we want to find. We want to find the maximum area. I always like to underline that in my word problem so I can really focus in on what I'm trying to find. So let's go ahead and see what I need to do to accomplish this. Well, as in most word problems, drawing a picture and assigning some variables is a great first step. So we know that we want to have a rectangle. So I'm going to draw a rectangle. And I know I want to find the length and the width of this rectangle. So I'm going to assign some variables to the length and the width. You can use X's and Y's, W's and L's, any letters that you like. I'm going to use W for width and L for the length. The other piece of information I think I'll put down here is I also know that my perimeter, which I'll use a P, is 80 meters. All right, now that I have a visual of what's happening, I need to come up with a primary equation. Well, this part can sometimes be tricky. What is my primary equation? Well, you always go back to what it is that you're trying to find. I know I'm trying to find the maximum area. That means I need an equation for the area of my rectangle. Well, we know that the area of a rectangle is the width times the length. That's my primary equation. Now the next thing I'd like to do is I'd like to write this primary equation using only one variable. Right now, it's in terms of two variables, both the width and the length. So how can I write it using only width or only length? Well, I'm going to make use of that perimeter number that I have. We often refer to that as our secondary equation. I know that because the perimeter is 80, that 2 times the width plus 2 times the length must equal 80, because that's the distance around my rectangle, or in other words, the perimeter. I can take this equation and solve it for one of those variables. Which one? It really doesn't make any difference. Choose the one that's easier to do. In this case, I would say they're equally easy, so let's go ahead and solve for L. So 2L is going to equal 80 minus 2W, and L will be 40 minus W. Well, what can I do with that? I'm now going to substitute it into my primary equation so that my area is now W times L, and I'll write L as 40 minus W. I now have an equation for area that's written all in terms of a single variable. If you like, you can even distribute that W across and say that the area is 40W minus W squared. Now, before I dive into the maximizing process, I want to think about a feasible domain. Right? Well, if I have a rectangle and I'm considering what possible values of W I can use, a lower bound would be 0. It doesn't make sense to have a rectangle that has a width of -5 meters, for instance. So my lower bound is going to be 0. Well, what would my upper bound be? Well, we can get that by looking at that secondary equation. Because if one possibility is that the width is 0, the other possibility would be that the length is 0. And if that happens, my width would be 40. So 40 will be my upper bound. So now we want to optimize, which in this case means finding the maximum. And in fact, we want to find the absolute maximum. So we know that absolute maximums can occur at the critical numbers, but they can also occur at the endpoints. We've already established the endpoints, so let's find those critical numbers. So we have to find dAdW. And looking at my function a, dAdW is going to be 40 minus 2W. Now looking at this particular equation, I know that it can equal 0. And it's going to equal 0 when W is 20. And it will never be undefined, so I don't have to worry about that. So the last thing we have to do is to check what's happening to the actual area when W is 20 and also when it's 0 and 40. So let's take a look. So at W equals 0, the area, let's look at our area equation now. In fact, in this case, it's probably going to be easier to use the factored form, because when W is 0, we're going to have 0 times 40, which is 0. When W equals 20, my area is going to be 20 times 20, or 400. And when W equals 40, the area is going to be 40 times 0, which is 0. Now we need to pick the largest value, which is 400. Now let's make sure that this answers my question. I want to find the length and the width of the rectangle that the perimeter is 80 meters and has a maximum area. That this happens when the width is 20 meters. So W is going to be 20 meters. But I still don't know the length. Well, if we go back to that useful secondary equation that we have, we can find that the length is always going to be 40 minus the width. So the length is 40 minus 20, or 20 meters. In this case, it turned out that a rectangle was really a square. I hope this was helpful. Thanks.